Hi, we're going to take a function f of x equals the absolute value of x, and we're going to discuss for what real values of x is this function differentiable. Now, to be differentiable means that the derivative exists at that particular x value. Well, we want to look at all real numbers to find out where the derivative exists. Then we'll be able to answer the question. Okay, so first, let's break this down into cases. Case 1, let's take all x values that are positive. So we say x is greater than 0. When that happens, the absolute value of this non-negative x is equal to x itself, of course. All right, so the limit, the derivative f prime of x for this x value greater than 0, it's equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now evaluate our function using f of x equals the absolute value of x. So we have the absolute value of x plus h minus the absolute value of x over h. We can drop the absolute value bars and just put parentheses because both of these values are going to be non-negative on the inside of the absolute value bars since x is greater than 0. Go ahead and simplify that. We get the limit of h over h, which simplifies to the limit of 1. That's just equal to 1. The limit of a constant equals that constant. So we're happy we got a real number. We go, aha! The limit exists. Thus, f is differentiable for x greater than 0. Check that off and consider the next case. We just did all positive numbers. Now let's look at all negative numbers. This is case 2. Let x be less than 0. In other words, let x be negative. Now, when x is negative, the absolute value of a negative number has to be equal to the opposite of that number. So we have negative x to get rid of the absolute value bars. And we have thus the derivative of f at x for these negative x's is the same limit as before, the absolute value of x plus h minus the absolute value of x over h. Now drop the absolute value bars and put negatives outside of parentheses minus a minus x over h, with the understanding this occurs because x is less than 0 and h is a positive number here approaching 0, which means that x plus h is going to be negative. And we clean up the top, and we're going to get negative x minus h plus x, which simplifies on the top to negative h. So we have the limit of negative h over h, and that's equal to the limit of negative 1. And the limit of a constant is that constant. So this limit, this derivative, is equal to negative 1. And again, we're happy because we got a real number solution. So we say, aha, the limit exists. Thus, the function f is differentiable for x less than 0. And that covers almost every real number except one real number, and that is x equals 0. That's case 3. And it's the more difficult of the other cases. X equals 0. Well, if the limit did exist, f prime of x would be equal to the limit as h approaches 0. H approaches 0 of the absolute value of 0 plus h minus the absolute value of 0 over h. And again, that only is true if the limit exists. Well, we're going to check to see if it does exist. We're going to consider the right-hand limit and the left-hand limit at x equals 0. Okay, now we already set x equal to 0, but now we have h approaching 0 from the positive side to check the right side limit. So here's this number h approaching 0 from the right side, which makes it ever so slightly positive. So we have 0 plus h minus the absolute value of 0 over h. And we'll do this little trick where we think of the number h as slightly positive since it's approaching 0 from the right side. We get the absolute value of 0 plus h plus minus the absolute value of 0 over h plus. Well, that's the limit of the absolute value of h plus over h plus. numbers are slightly positive, and that is equal to h plus over h plus. We don't need a negative sign in front. This occurs because h is approaching 0 from the positive side, which makes it slightly positive. Okay, and that means that the h pluses cancel each other, and we get the limit of 1, which is equal to 1. Okay, now that is the result of finding the right side limit, L plus. Now let's find the left side limit. In other words, we already set x equal to 0. Now let h approach 0 minus. Oh, now h will be a number that's only slightly negative. So we have the absolute value of 0 plus h minus the absolute value of 0 over h minus. That's the absolute value of h minus over h minus, which is minus h minus over h minus. And that occurs because here we have h approaching 0 from the negative side, which makes it ever so slightly negative. And so we simplify and get the limit equal to the limit of negative 1, which is equal to negative 1. And that is our left side limit. L minus is negative 1, L plus is positive 1. Okay, that's Thus, the function f is not differentiable at x equals 0. And the reason why is because a limit doesn't exist at x equals 0. The right limit does not equal the left limit. The conclusion then is that the derivative f prime of x for this function, absolute value of x, is equal to 1 when the x values are positive and equal to negative 1 when the x values are negative. So if we were going to say this in simple words, we'd say f of x equals the absolute value of x is differentiable everywhere except at x equals 0. All real numbers except x equals 0. It's interesting to look at the sketch. I think we'll take a quick look at the sketch and meditate on it for a while. First, the sketch of the original function, f of x equals the absolute value of x. That's the V for victory sketch. F of x equals the absolute value of x. And the sketch of the derivative function, it is a function, you know. We see that for positive x values, we get y values equal to 1, and for negative x values, we get y partners equal to negative 1, and at x equals 0, we have nothing. It's not defined there.